Right, another past examination question. So this was taken from Edexcel. It was a Core Mathematics C3 question from June 2008, and this was question number 1 from that paper. So let's have a read. The point P lies on the curve with the equation y equals 4e to the 2x plus 1, and the y coordinate of P is 8, and in part A we need to find in terms of ln2 the x coordinate of P. So let me try part A over here. First of all, let me copy down the equation of the curve. Y is equal to 4e to the power 2x plus 1. And we know that the y coordinate of P is 8. So let me simply put y is equal to 8 into this curve equation. So by doing so, we're going to have 4e to the 2x plus 1, and that is equal to y, which is 8. And if I divide both sides by 4, we're going to have e to the power 2x plus 1, and that is equal to 8 over 4, which is 2. Now, if you take ln's on both sides, you're going to have 2x plus 1, and that is equal to ln2. And if you take the plus 1 to the right, 2x is going to be ln2 minus 1. And rearranging for x is going to be dividing both sides by 2, ln2 minus 1, all divided by 2. So that should be the x coordinate of P. So the x coordinate of P in this case is ln2 minus 1 divided by 2. So that completes part A. Now for part B. Part B, let's have a read. Find the equation of the tangent to the curve at the point P in the form y equals ax plus b, where a and b are exact constants to be found. So let me try part B here. So if you're unaware in terms of how to calculate the equation of the tangent, I have created videos on the channel showing you how it's done, and I provide links to those videos in the description below. Now firstly, we have the equation of the curve y equals 4e to the power 2x plus 1. Whoops, so let me be as neat as I can. And we have the point, so we need the tangent at the point P. P has an x coordinate, so from part A, here's the x coordinate. Let me copy that down. So the x coordinate is, so let me copy that down here. So it's ln2 minus 1 over 2. So minus the 1 divided by 2. And the y coordinate is 8. So that's the coordinate of this point P. But for the equation of the tangent, we need the gradient of the tangent, and for the gradient, we need the gradient function. So the gradient function implies dy over dx. So we need to differentiate. So when we differentiate this exponential function using the chain rule, we should get 4e to the 2x plus 1 multiplied by the derivative of 2x plus 1. So when you differentiate the 2x plus 1, that will give us a 2. So dy over dx, so let me tidy this up, dy over dx would be 4 into the 2 from here, that is 8, so it's 8e to the 2x plus 1. Now if you're unaware in terms of differentiating exponential functions, I have created videos on the channel, and I'll provide links to those videos in the description below. So be sure to check out those videos. Now further to that, we've got dy over dx, the gradient function, but let's work out the gradient of this tangent. So in the next step, gradient of the tangent. And for the tangent gradient, I usually name that m1. So m1 is the tangent gradient. So to calculate the tangent gradient, all that we need to do is replace the x coordinate of the point being ln2 minus 1 divided by 2 into the gradient function dy over dx. So let's do that. So we'll have 8e to the 2. Now the x coordinate is ln2 minus 1, so ln2 minus 1 all divided by 2, okay, plus the 1, so plus the 1, let's not forget that, and we can therefore cancel these two 2's, okay, and if I continue along the line, so we have 8, so 8 from here, e to the power, and ln2 minus 1 plus 1, that can certainly cancel, the minus 1 plus 1, to give us 8e to the ln2, so that's the term that remains. And let me remind you of another useful result. Here's another useful result. E to the ln a is a, so that is a useful result to know. So if e to the ln a is a, e to the ln2 is 2, so Rm1, the tangent gradient, would be 8 into the e to the ln2 being 2, and 8 into 2 is 16. So 16 would be the gradient of our tangent. Now, mathematically speaking, a tangent is a line which meets the curve at one point. So it's going to be a line meeting our curve at the point P. Since it's a line, let's use the equation of the line formula to work out the equation of the tangent. So the equation of the tangent at the point P. So here's the line formula. I'm going to be using this formula, y minus y1, that is m into x minus x1. So x1 and y1 are the coordinates where this line or tangent passes through. So the x1 and y1 passes through P. P as coordinates ln2 minus 1 over 2. So ln2 minus 1 all divided by 2, that being the x coordinate. The y coordinate from the question is 8. So let's copy that down. So that's the coordinates of this point P. Whereas m is the gradient of our tangent, that being 16. So we calculated that in the previous step. Upon substitution, let's see what we're going to get. Y minus. Y1 is 8. So it's y minus 8 on the left hand side. That is equal to m which is 16, into x minus x1. Let's copy that down. So that is ln2 minus 1 all divided by 2. Let me be as neat as I can. If we get rid of the brackets, we're going to have, so let me continue here, y minus 8 on the left hand side. As far as the right hand side is concerned, 16 times x is 16x minus 2 will cancel with the 16 8 times, so it's minus 8 into ln2 minus the 1. So let me be as neat as I can. So it's ln2 minus the 1. This is the term that remains. Okay. And if I multiply the brackets, if I get rid of the brackets, we're going to have y minus 8 on the left. That is 16x. Minus 8 times ln2 is minus 8 ln2. Minus 8 times minus 1 is plus 8. And if you take the minus 8 to the right hand side, you're going to get the solution for the tangent as y equals 16x minus the 8 ln2, 8 plus the 8, which is 16. So this should be the solution for the equation of the tangent to the curve at this point P, and that completes part B. So not only it completes part B, we've completed the question in its entirety, so that sadly ends the video. If you did enjoy the video, be sure to like and subscribe for more content like this, and I hope to see you again. Thank you.